A species of plant has stems whose lengths are known to follow a normal distribution with a mean of 30 centimeters and a standard deviation of 4 centimeters. So in other words, X is a normal with 30 and 4 squared. Two studies are undertaken to see if there's been a change in this mean length in a population of these plants that were introduced to a new environment several years ago. Test at the 5% level, given the results, so we have the results here for study 1 and study 2, and what should the conclusion be from each study? Well, we know here that the null hypothesis is that mu is equal to 30. The alternative hypothesis, because we're just looking for a change, is mu is not equal to 30. That means we get a two-tailed test. Now remember, our test statistic is Z, the standard normal, and from example 1, with a 5% level, that means 2.5% at either end, and we can remember that our Z value for that was negative 1.96 and 1.96. In other words, we've now defined our critical regions for the test. So if we look at study 1, the test statistic for that one, let's call it Z1, would be 28.5. Take away 30 divided by 4, and for this study they took 25 plants, so the square root of 25 is 5. So we can work out that test statistic. And then for study 2, let's call it Z2, that's going to be 32.5 take away 30 divided by 4 over, they took 36 plants, so that one is 4 over 6. And again, we can calculate that. So let's calculate each of those. So for the first one, we've got 28.5 take away 30 divided by 4/5, and that's negative 1.875. And for the other one, we've got 32.5 take away 30, and that would be over 4 over 6, and that gives me 3.75. So 3.75 would be way up here. Negative 1.875 would be somewhere around here. So for study 1, we would accept H0, situation of no change. For study 2, we'd have evidence to reject H0 and say that the mean has changed. Now the last thing that we're asked to do is combine the study. What would happen if we combined the studies? So what we need is a new X, capital X bar call it, which is going to be the mean for the combined studies. So it's a weighted mean. We're going to have 25 lots of 28.5 and 36 lots of 32.5, and we need to divide that by 25, add 36. So let's calculate that. So 25 times 28.5, add 36 times 32.5, divided by 25, add 36, gives me 30.86. So my combined study, let's call it Z combined, is going to be 30.86 take away 30 divided by, well, standard deviation is still 4, 25 add 36 is 61, because we now have 61 in the test. Remember, it's the n that goes in here in the formula. Okay, let's calculate that. So I've got 30.86 take away 30, and that's divided by 4. Actually, let's just put the template there first and then go 4 over the square root of 61, and that gives me 1.679, which, as we can see, is not in the critical region, and therefore we would accept H0 and say that the mean has not changed due to the new environment if we use the combined study.